Hey guys, what's up? It's Eric with Vdiagtool Vd70S. Welcome back to the channel. Welcome back to another video. So I just got here to the shop. We got called out to come take a look at a Mercury Grand Marquis. I'm not exactly sure what year it is, but we'll find out when we go inside. Now, I did talk to the shop owner over the phone, and basically what he's telling me is that the engine is running rough, it's stalling. They've already tried replacing the fuel pumps, spark plugs, things like that. They're not really sure where to go next, so they wanted me to take a look at it. Like I said, I just got here, so I'm gonna head inside. I'm gonna talk to the mechanic because I kind of want to get his side of the story first, and then I'll get back with you guys afterward. All right, guys, so this is what we're working on today. It's a 2003 Mercury Grand Marquis. It's got the V8 4.6 liter engine. Now, the shop is telling me that the engine is running really rough and it's stalling. Originally, it came in with the no start condition. They replaced the fuel pump, and they noted that it had really bad gas. If you take a look over here on the left, you can see this is a sample of the original gas that was in the car, and this is a sample of the fresh gas. So the first thing I want to do is run a full scan using my scan tool. Today we're going to be using the Vd70S by Vdiagtool. Let's go ahead and start by selecting manual diagnosis. We're going to choose America, Ford. Let's do automatic detection. Select Grand Marquis. It's asking us if we have traction control. Let's cycle the key off and then back on, see if we have a light for the traction. And we do. It was right up here on the left hand corner. Let me cycle that key again and pay attention. That's our traction light. So yes, we are equipped. There's our year, make, and model. Hit OK. Let's go ahead and choose automatic scan. This is going to automatically scan all of the modules in the car. All right, so we're done with our scan. That was pretty quick. I mean, this car only has 6 modules. And as you guys can see, we only have fault codes in one module. That's going to be the PCM. Now, what we can do while we're here is generate a report. This is going to allow us to save and share this information. Successfully saved. Let's click on our PCM. And the code that we have stored is a P1000. Onboard diagnostic systems readiness test not complete. Basically, what that tells us is that somebody recently came in here and deleted all the codes. So that means that we're not going to have any fault codes to go by, which is no big deal. I mean, it's not like we've never diagnosed a car that didn't have any fault codes before. We're just gonna have to do this one the hard way. But if you guys know anything about me, I love a challenge, so let's see what we can figure out. So let's go ahead and crank this engine over and verify the concern. As you guys can hear, we had a really long crank. The engine is running right now. Let's take a look under the hood. You guys can see the engine is running. Now, it is running a little bit rough. Sounds like it might have a misfire. Now, one of the things that I did notice right off the bat is that when this thing finally started up, we had some smoke coming out of the tailpipe. Now, the symptom of a long crank to me is giving me indication that we may have a problem with maybe a leaking fuel injector. Let's shut this thing back off. Now I'm gonna try to crank it again. Take a listen to the engine. You guys hear how we have that long crank? Let's see if we can catch the tailpipe over there. All right, so it's a lot more noticeable over here. You can see we got a bunch of smoke coming out of the tailpipe. Definitely smells like raw fuel. Sounds to me like we might have a stuck open fuel injector. Now, what I'm hoping is that maybe we can use the misfire counters in the scan tool to kind of narrow down what cylinder we're looking at. So I'm gonna start by going into the PCM, and we're gonna select special function. Let's see if this thing gives us a power balance test. I don't see one right here. Let's try actuation test. Let me scroll down. Okay, we don't have a power balance test there. Now, this being a 2003, it may or may not have that capability. I'm not sure what year they started implementing that. Let me back out of here. Let's try going into service, powertrain. No, it's not there either. Yeah, I don't see a power balance test here on this menu. Now, this likely has nothing to do with the scan tool. This is probably because this is a 2003, which is an older model, and I don't think on these years they actually support a power balance test. However, that doesn't mean that we can't find misfire data in the live data stream, so let's go back into the live data. So I went ahead and reselected our vehicle. Now I'm gonna go ahead and select live data. Okay, so looking at our live data, let's see if we can find anything that has to do with our misfires. Okay, guys, so unfortunately, the only data pit that I could find that had to do with misfires is going to be this number 160 total misfires number. It's not exactly telling us what cylinder it is, but it will let us know whether or not we're actually having a misfire. So I'm going to go ahead and start the engine up. You guys hear that long crank? Our engine is now running. Let's take a look at the counters. All right, so as you guys can see, we are counting on the misfires: 14, 16, 17, 21, 22. Definitely this engine is misfiring. However, this is not going to tell us what cylinder it is we're having the misfire on, so it's not really going to be of much help. One other thing that we can try and do is go into the mode 6 data. Now at the main menu, instead of selecting Ford, we're going to go ahead and select OBD2. This is going to take us into the global OBD data. We're going to do auto scan, and from here let's go into mode 6. Let's see if we can find our misfire data. So to find our cylinder specific misfire data, we're going to go into test ID number 53. And this is going to list cylinders 1 through 8. So let's start out by taking a look at cylinder number 1. And if you look at our test value, you can see it's 0. So is our max limit. So we don't have any misfires there. Let's try number 2. Again, we're just showing zeros here. And the status is pass. Let's try cylinder number 3. Zeros, pass. Cylinder number 4. Zeros, pass. Number 5. Zeros, pass. Number 6. Zeros again. Number 7. Zeros. And finally number 8. We got zeros. Okay, so I think the problem here, we already know somebody came in here and deleted all the codes because we have that P1000 code. So I think right now the car hasn't been run long enough to complete a trip. And this is essentially what we're looking at, is trip data. So you would have to drive this car a full trip in order for it to register any information here. Unfortunately, we don't have the luxury of driving this car. And quite honestly, when it's misfiring this bad, it's not a good idea to run it very long because you could damage the catalyst. All right, guys, so the next test I decided I wanted to do was just to go ahead and do an injector balance test, so that we can determine if one of these injectors is bad. So basically what I'm gonna do is I'm gonna go ahead and hook up my fuel gauge. We're gonna start by removing the cap on the Schrader valve up here. So I'm gonna go ahead and screw on the hose adapter. And we're gonna connect our gauge. Now, I will say that my gauge has seen better days. And if you take a look, its resting pressure is somewhere around 5 PSI. So these readings may not be perfect. We're gonna have to take this into account when we take our readings. But let's go ahead and connect this. All right, guys, so before I actually start the test, I do want to take a look real quick and see what our pressure is when the engine is running. So again, right now, I haven't started the engine and our gauge is sitting somewhere around 5 PSI. So let's go ahead and crank this engine over and watch this gauge. So we're going to be looking through the windshield, and I'm going to cycle the key off and back on. I'm going to go ahead and crank it. Okay, I'm not getting any pressure there. Let's try that again. Try it again. Okay, so now the engine doesn't even want to start. Hang on. I forgot to put the PCV hose back on and plug this vacuum tube back in. Okay, so let's try that again. I'm gonna go ahead and crank it. Okay, so the engine is running, but I'm still not showing the pressure. There might actually be a problem with my fitting here. Let me move it around and play with it. See if we can get some pressure to show up. All right, guys, so fast forward. I decided to go ahead and switch over to this Y fitting right here. So we got the line connected directly to the fuel rail and directly to the fuel supply line. Now the Y fitting is connected to my gauge over here. And as you can see, we're still only showing about 14, maybe 15 PSI. Now, I don't know if this is a problem with my gauge. I mean, I find it really hard to believe that the car is running on only 15 PSI. I mean, if it were, this thing would be running really lean. All right, guys, so just out of curiosity, I wanted to see if the engine is actually running lean. So right here, I got the scan tool. And if you take a look, you can see our short-term fuel trim on bank 1 and long-term fuel trim on bank 1. So long-term is somewhere up around say 13, but you can see that our short term is counteracting, so we're going negative on the short term, and the same thing is happening here on bank 2. So you can see long term is positive 15 and the short term is negative 12. Yeah, right now this doesn't seem to be running lean. I'm gonna chalk this up to being a problem with my gauge. I'm gonna have to get with the Snap-on truck and see if they can exchange this gauge. All right, guys, so you know what, I take back everything that I just said. I double checked my gauge and made sure that all of my fittings were good. Everything's good, the Schrader valve and all of that. As far as the hose connections, there is no problem with the fuel pressure reaching the gauge. I think our problem here is that we actually don't have enough fuel pressure reaching the engine. Now, one of the things that made me realize this is that when I try to accelerate this engine, it pretty much just falls flat on its face. If I rev it up, the engine just bogs down and starts back popping. It really sounds like it's starving for fuel. Let me show you guys. So I'm gonna go ahead and crank the engine. Again, we got that long crank. The engine starts, it runs okay. It's got a slight misfire, but take a listen to what happens with the engine when I try to accelerate it a little bit. You guys hear that back popping? You guys heard that? That back popping is the sound of the engine starving for fuel. Pay attention to the fuel gauge. So I'm gonna rev it up. And again, you can see we can't even get to 20 PSI. The engine is bogging down. It does not want to accelerate. If I let off, it goes back to running okay. So yeah, this definitely has to do with the fuel supply issue. All right, guys, so the next thing I want to do is I want to take a look at our fuel rail pressure sensor. So right here, you can see we got our fuel rail pressure in PSI. and the voltage for the sensor, and then up here we have the command for the fuel pump. So let's go ahead and crank this engine over and pay attention to these data PIDs. So again, we got this long crank right here, and you can see our fuel rail pressure right there is matching 15 psi. That's what we were showing on the manual gauge. So that is matching what we're showing. And right now the duty cycle command for the fuel pump is 48.9. Again, guys, we only have 15 psi worth of pressure in the fuel rail. I think the spec for this one is somewhere between 30 and 40. Let's see what happens when I rev it up. You guys see it dropping 11. Yeah, this thing is not able to maintain the pressure. Yeah, this is not looking good. So if I'm not mistaken, and mind you, I could be wrong about this, but I'm pretty sure, if I remember correctly, seeing about 50% on the duty cycle for the fuel pump command is saying that the computer is basically trying to push the fuel pump to the max. Seeing 50% duty cycle is pretty much like saying it's 100%. This is leading me to believe that the problem might actually be with the fuel pump inside the tank. Now, like I mentioned before, they did replace the fuel pump. This, I believe, is the old one. And if you take a look here on the hanger assembly, we have the actual pump itself. Now, what I'm guessing that we may have a problem with is likely something to do with this hose connection right here where the pump goes. I don't know if the hose might have come loose and it's leaking internally, or maybe we have a problem with the pump itself. Now, one of the things I would like to test before, telling them to drop the fuel tank is we can come back here into the trunk area. Down here is where the fuel pump control module is located. This fuel pump control module is what actually sends the power to the fuel pump in the tank. And if you look closely, you can see that somebody's already been in here. You can see we got holes in the wires where somebody was poking around and doing some testing. All right, guys, so we're connected over here. Now, I know this might be a little bit of overkill because I'm pretty sure that our problem is with the pump in the tank, and that's noted by the fact that we have a really long crank time, which means that the fuel rail is not maintaining the pressure. So more likely the culprit is that we have a leak inside the gas tank. But I just wanted to make sure everything over here is good before I tell them to drop the tank. So right now you guys can see that I'm back probed on the power feed wire that goes to the fuel pump from the fuel pump control module. And as you can see on our meter, we do have battery voltage. And if I use the load testing function on this tool, so pushing this little button right here activates the load tester, and you can see our test light lights up nice and bright. That means we got a good power feed there. We could also start up the engine, so I'm gonna go ahead and crank it. The engine is running, and we got system voltage with the engine running. Okay, so I switched my back probe over to the ground control circuit, and as you can see, with the key on, we have system voltage. Now, when we start the engine up, the computer should ground that circuit. And as you can see here, we do have a ground. Now we're gonna go ahead and load test this ground. And you can see the test light lights up nice and bright. So that's a good power and a good ground to our fuel pump. This tank's gonna have to come down. All right, guys, so it looks like we found our culprit. You can see they got the fuel pump removed from the tank. And if you take a close look at this nylon hose right here, we got a hole in the tube right there. All right, guys, so they just got done putting in the replacement pump. Let's go ahead and start this thing up and see what our pressure is. And bam, there's our pressure, 35 psi, right at the spec. Let's see what happens when we rev this thing up. The engine sounds way better. Now take a look at that fuel pressure. That's what we want to see right there. We're getting upwards of 40 psi. The engine sounds great. It's got plenty of power now. That's a fix.